In this video, we're going to be covering the practice problems for Unit 2, Notes 3. Starting off with number 1, what determines the sequence of the elements from the first to the last? Well, that is going to be the atomic number, which is also, if you know, the number of protons. I think we've mentioned that several times throughout the lecture, but the atomic number, again, is the number of protons, and that's how we order all of the elements. Number 2 says, what is the difference between a group and a period on the periodic table? Well, groups are columns and periods are rows. So that's how you would have to remember that. The groups are columns and periods are rows. Traditionally, though, and for the next couple of lectures, we're going to be focusing more on the groups rather than the periods, just because there's more similarities in elements when they're found in groups. Moving on to number 3, how can you determine the total number of electrons that an atom has from the periodic table? Well, the total electrons should equal the number of protons. Okay, and I emphasize the word total just because there's a difference between the total electrons and the valence electrons, and that's going to be the next question. How can you determine the number of valence electrons that atoms in groups 1, 2, and 13 through 18 have? That is going to be basically you count the tall columns. Okay, so for all the tall columns that you have on the periodic table, skipping that short middle section, you're going to count from 1 to 8 from left to right. And just like how we reviewed in the notes, the number of the column is going to be the number of valence electrons for those elements that are found in that column. Number 5 says, write the name and symbol for the element that has 48 electrons. Well, if you pull up a periodic table and try to find the element that has 48 electrons, well, you would actually have to look for the element that has 48 protons if you're assuming that the number of electrons and protons is the same. The element that has 48 protons is cadmium, and then the symbol for cadmium is capital C, lowercase d, Cd. Number 6 says, name 2 elements that have properties similar to sodium, Na. How many valence electrons does each of these 3 elements have? So you'd have to find sodium on the periodic table. Sodium symbol is Na. That's because its Latin root is natrium, so that's how we get the symbol Na. And I actually wrote down all of the elements that are in the same family, in the same group. There's lithium, potassium, cesium, and francium. And all of these have 1 valence electron. So you could have written down any of these 2, and they all have 1 valence electron. For number 7, name 2 elements that have properties similar to bromine, Br. How many valence electrons does each of these 3 elements have? So I'm going to put down the rest of the elements that are in the same family. I believe there's one more, but they all have 7 valence electrons. I'm going to go ahead and put that in here. 7 valence electrons. Okay, so there's the answer for number 7. For number 8, we want to fill in this chart, and hopefully you were able to fill out this chart on your own. And I'm just going to show you the answers here and kind of describe what's going on. For the electron configuration, I just went in the order of the electron orbitals and filled them up as I went. And just as a review, each s orbital can hold a maximum of 2 electrons. So we have like 1 s2 and then 2 s2. Each p orbital can hold a maximum of 6, so this one has 6. And then I just keep on filling up all of the electrons until I run out of electrons. And the number of electrons is going to equal the atomic number. So the atomic number, which is the same as the number of protons, which is also the same as the number of electrons, that will tell me how many electrons I have, and that's how many I have to fill in. So these are all the electron configurations for all of these elements. And if you wanted to double check, the way you could do that is by adding up all of the indexes, all these exponents. When you add those up, they should equal the same number that you have over here. Now, I'm going to skip this column, the valence electrons. I'm going to come back to that. But the highest energy level, the way you would determine that is you take a look at the big number. So I'm going to go use my highlighter here, and I take a look at the big number. So I have 1, and then I have 2, and then I have 2. So the biggest big number is going to be 2. Okay? And likewise for over here, I have 1, 2, and 2. So the biggest big number is 2. I'm going to skip a few of these and then maybe do like one of these. For phosphorus, the biggest big number is 3. Okay? And so that's the highest energy level. That's the maximum amount of energy. All right. And so that actually brings us back to the valence electrons. There is that shortcut method that you could have used for the valence electrons by counting the columns left to right from 1 to 8. But there is another way you could do this if you didn't have a periodic table. If all you had was the electron configuration, to find the number of valence electrons, the number of valence electrons is the number of electrons in the highest level. Maybe I should write that down somewhere so that you can make a note of this if you would like. The number of electrons in the highest energy level. So for instance, the first couple ones, the highest energy level was 2. So I'm going to pull out my highlighter here, maybe do a different color, and then smaller highlighter. So in this second energy level, I have 2 electrons here and then 6 here. So if I add those up, I get a total of 8. 2 is my highest energy level, so I have 2 plus 1, and that gives me 3. And then let's do this bottom one here as an example. I have 3 as my highest energy level. And then in that energy level, I have 2 over here and 3 over here. And I add those up and I get 5. So that's just a different way that you can actually figure out how many valence electrons if you didn't have a periodic table and you didn't want to do the shortcut method.